My heart's like a flute and I want to play all day. Jesus Christ is my music master. Deep from my heart flows a simple melody. Great is His love, love without end. Great is His love, love without end.
Bible reading. A reading from the Holy Book of Psalm, chapter 103, verses 1 to 2. Bless the Lord, O my soul, and all that is within me. Bless his holy name. Bless the Lord, O my soul, and do not forget all his benefits. This is the word of the Lord. Thanks be to God.
Good morning, one and all present and watch this webinar. I feel honored to welcome our correspondent, Reverend Father Dr. Sebastian, who always guide us and support us. I welcome our admin father, Dr. S. Arakidas, who always fulfill our needs, and I welcome our principal, Dr. S. Suresh sir, who always encouraging us for conducting event, seminar, workshop. It's my pleasure to welcome our chief guest, Dr. P. Thiyagarajan sir, Assistant Professor, Department of Computer Science, Central University of TamilNadu, Thiruvarur. I thank here to accepting our invitation. I welcome our Dean of Science and all the faculty members of the department and my dear friends. I am sure that you all will feel enriched with knowledge after completion of this event. I welcome you all once again to this seminar and hope that you all will have a great time ahead. Thank you.
At the outset, on behalf of the management, our sincere, enthusiastic, time-conscious, author of social research methods and introduction, our secretary and correspondent, Reverend Father Dr. Sebastian, an energetic and efficient man holding many conferences and seminars at national and international level, Reverend Father Dr. S. Arakidas, Administrator. I congratulate Dr. Sujit, Head the Department of Computer Science, for arranging this wonderful webinar on overview of machine learning on 4th June 2020. In our college, this department is one of the department organizes more and more conferences and workshops last year. We also appreciate our chief guest, Dr. P. Thiyagarajan, Assistant Professor, Department of Computer Science, School of Mathematics and Computer Science, Central University of TamilNadu, Thiruvarur, for accepting our invitation and act as chief guest for this webinar and present his views on overview of machine learning. Machine learning is an application of artificial intelligence that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. Machine learning focuses on the development of computer programs that can access data and use it to learn for themselves. Machine learning also has intimate ties to optimization. Many learning problems are formulated as minimization of some loss. The many applications for machine learning includes agriculture, anatomy, banking, bioinformatics, computer networks, credit card fraud defects, DNA sequence classification, financial market analysis, insurance marketing, etc. Our chief guest, Dr. P. Thiyagarajan, explains more about machine learning in detail. We pray our God Almighty Father for shower His blessings for the webinar grand success.
Good morning, my dear friends. I'm really happy that Annai Vailankanni Arts and Science College Department of Computer Science is organizing webinar on an overview of machine learning. And machine learning is go of the day today. And at this time of Corona, COVID-19, and this department has envisaged this program. I hope this will be very useful for all the students and other faculty members or research scholars who attended, and I wish you all good luck. And I wish that this problem will be solved soon and we will have a lot more learning, teaching experience as students and as staff. And once again, I thank and appreciate the head of the department of this computer science department, Dr. Sujit, and all his members and the team members. And also I'm glad to know the Central University professor, Dr. P. Thiyagarajan, will be the resource person for this webinar. I welcome him and appreciate him. And I thank you all for this participation and for your active involvement. Thank you.
Good morning to everyone. I am glad to give felicitation address. On behalf of Annai Vailankanni Arts and Science College, Thanjavur, I appreciate Dynamite Dr. K. Sujit, IQSC Coordinator, HOD, PG and Research Department of Computer Science, and his energetic team members who organized this webinar on emerging topic and overview of machine learning. He organized several workshops, seminars, and symposiums successfully. We are privileged to have an eminent resource person, Dr. P. Thiyagarajan, Assistant Professor, Department of Computer Science, Central University, Thiruvarur, who is going to enrich your knowledge. I invite all the professors and scholars from various universities and colleges who are going to make this program a meaningful one on this pandemic situation. Once again, I appreciate everyone. Thank you.
Good morning everyone. I am very much glad to introduce our chief guest, Dr. P. Thiyagarajan, Assistant Professor, Department of CS, Central University of TamilNadu, Thiruvarur. He completed his PhD in Computer Science in the year 2014. His area of research is network security, and also he completed his postdoctorate in the year 2015. He published a good number of papers in international journals and conferences. He conducted various workshops and presentations. He got more than 75 citations with good number of H index and I-10 index. Now he is going to present a webinar on an overview of machine learning. Thank you.
A very good morning to all present for this webinar, and for the next 1 hour we are going to discuss on the topic overview of machine learning. And this webinar is being organized by Annai Vailankanni Arts and Science College, Thanjavur, and myself Thiyagarajan, working as Assistant Professor in Department of Computer Science, Central University of Tamil Nadu. The next 1 hour we are going to discuss on the topic which is projected. We are going to discuss on what is machine learning, difference between machine learning and data mining. What are the components of machine learning? How the machine learning algorithms are categorized? What is deep learning? How machine learning is different from the deep learning? What are the various ways in which we can apply the deep learning? We are going to see the connection between the machine learning, deep learning, and the artificial intelligence, and the Python libraries by which we can easily implement these machine learning algorithms. We're going to see last the features of machine learning. What is machine learning? As the name goes, machine learning is nothing but how we can able to incorporate the knowledge to the machine so that machines also will think like humans. This is what the ultimate object of the machine learning. But humans learns from the environment. If there is a fire, we will not touch it because we learn from the environment. We learn from the surroundings. Either parents or some of our close friends in the surroundings might have said when you are a child that if you touch the fire, it will hurt us. So we learn from the environment and we store in our knowledge and we use it at appropriate times. This is how we learn. The machine also learns in a very similar way. So the machines to incorporate the learning ability autonomously to the machines so that learning can take place based on experience, observations, and analyzing pattern the given data set is called machine learning. For the machine learning, you need not explicitly program. You need not have to build a knowledge for the machine. You need not write a code, but it will learn from the data using some algorithms. That is what machine learning. Let's again go through the definition. Machine learning provides the ability for the machine to learn autonomously, independently based on experience, observations, and analyzing patterns in the given data. If some data is given, the machine will be able to analyze the pattern among the data. So this has to be done autonomously. This is what the machine learning is. So when you write a program or a code for any given problem, what we'll do, we'll actually write a set of instructions starting from 1 to 10 lines, write a set of instructions, and the program will execute each and every line to get the desired output. Whereas machine learning is little different. Machine learning will give the data set as an input. This data set will have many number of features or nothing but columns, and it has many number of rows. So that is given as an input for the machine learning algorithm, through which the machines will learn by itself, by analyzing the data to find out the patterns in the data set. And with the help of the pattern, the machines will automatically can make any decisions based on the observations from the data set. This is what the machine learning will do. So once the data set is given, it analyzes the patterns. And with the help of the patterns, it can able to take some decisions independently based on the patterns which is learned from the data set. For example, if you take a photo and family photo and upload it in the Facebook, you might have encountered this in the Facebook, that Facebook will say that please tag X persons, please tag Y as the person name in the photo. The Facebook itself will recommend that this person located on a left is X, this person located on a right is Y. How come the Facebook will know that this is the person X and this is the person Y? This is the facial recognition machine learning algorithm. Through your friend list, each and every profile will have, in the Facebook profile, have a photo, right? Profile photo. Are the photos in their album. They will analyze the friend list, and whenever you upload your photo, they will try to match the facial features in the photo with the photos in all the profile picture in the friend list. Once the profile picture in the friend list matches with the entity in the photo, it will then identify and recommend you to add that as a person X and add the tag as a person Y in the photo. This is an example of the Facebook, how the machine learning is used. And even we can have one good example like voice assistant, like Alexa. Alexa, you know, right? Alexa is a product, Google product. Whenever you want to search some music, and if you say I want to play some Thiyagarajan music, then to the Alexa will search in the database and it will play the desired song for you. If even for the voice assistant, we use this machine learning. How do machine learn? This next question is that how do machine learn? The machine learn nothing with big difference. It is learning the things exactly as how human does. How we learn, the same way the machines also learn. How we receive the knowledge? We receive the knowledge about a particular object from the surroundings or through a person. And then we keep that knowledge in our mind for quite some time. And whenever we encounter that object, we automatically recall the knowledge from the memory and we'll use it whenever we encounter the object in the future. The same way the machine learning also learns. Machine learning also learns exactly the same way how human learns. So the knowledge is stored in the mind, and whenever you encounter the same object in the future, it will dig the knowledge which is stored in the brain and it will apply it for the current situation. The same way the machine learning also does. What does it do in general human beings? Whenever you see an object and you store the knowledge in the brain, and whenever you encounter that object currently, the brain trains itself and tries to find the knowledge which is already stored. Suppose when I'm looking at the fan, the brain analyzes the features of the fan. It has 3 wings. It will be in the ceiling. It will spin in a high speed. These are some of the futures. And these futures, along with that item name, will be stored in our mind. And in the near future, whenever I see a fan, the training is already, so brain trained the futures and it is stored. Whenever in the future I see the fan, the patterns will be analyzed in the storage brain and it will visualize as that is the fan based on the futures. Because already futures is stored in the brain, and whenever you see the same object in front, those futures will be again mapped with that concept which is stored in the brain, and it will visualize, oh, this is a fan which is already we have seen some time back. Exactly in the same way, the machine learning also does. So machine learning is not a very new research line. It has originated in long back in 1943, but it has been quite popular now because of the infrastructure and the computational facility which we have now. So the machine learning, in fact, was introduced in 1943 in the name of neural network. And in early days, the machine learning was very slow, because I said, because of the high computational cost, and many institutes and many research labs could not able to afford because of the cost. And because of it, it was not much popular. But with the help of internet, and we are living in the 21st century with the help of the computing infrastructure at a very reasonable price, now we can able to afford this machine learning. And moreover, with the help of IoT, we can able to have a lot many data now per day. We're generating around quintillions of data. Quintillions is nothing but around 10 to the power 18 bytes of data we're generating a day. And with the help of it, we have the data, we have infrastructure, and these both brings the machine learning live, and it has become more popular because of its impact in the real life world. This makes the machine learning back into the form. So we'll see a quick timeline chart which demonstrates how the machine learning has grown since from 1950 till now. In 1950, Alan Turing created a test to check whether the machine could fool a human being into believing it was talking to a machine. In 1952, slowly it has been evolved, and the first computer learning program, a game checker, was written. Arthur Samuel is the author of the program. And slowly in 1957, we have this first neural network for computers, was invented by Frank, which stimulated the process of human brain. In 1967, the nearest neighbor algorithm was written, and in 1979, the students of Stanford University, California, invented the Stanford card, which will navigate itself. It will travel itself inside the shopping mall, avoiding the obstacles in their way. In 1997, IBM written a program that play chess. In 2002, we have the machine learning library named Torch was released. In 2016, the AlphaGo algorithm, it was developed by the Google, managed to win 5 different games, and it won 5 games out of 5 the Chinese board game. So this is how the machine learning has evolved. So gradually, you can say the advancement from 1915 to 2016. So already you might have some knowledge about the data mining, and there is a very marginal gap between the data mining and the machine learning, and it is very important to know what is the main difference between the machine learning and data mining. So we are going to see the difference between this machine learning and the data mining under the 6 features: age, purpose, what they use, human factor, how they are related, and how they are used. First, age. Data mining is otherwise also known as KDD, that is knowledge discovery in databases. It was popular and it was injected around 1930, whereas machine learning appears in 1950s. The purpose of the data mining is simply a method of researching to determine a particular outcome based on the total of the gathered data. Data mining objective is to give some outcome among the data set is available. Whereas machine learning, which trains a system to perform some complex task, and then use the training system to predict something which is there in the future. That is what machine learning is all about. And what they use, data mining use the vast stores of data, that is big data, whereas machine learning on the other way use or works with algorithms, not on raw data. And human factor, data mining relies on human intervention, and it is ultimately created for user by the people. And machine learning, the whole reason for existing is that it can teach itself and not depend on human influence or actions. How they are related, how machine learning and this data mining are related. Data mining is a process that incorporates two elements. It includes a data set or database, and it has machine learning algorithm also. Whereas machine learning algorithm need not necessarily include the data mining. And data mining is mainly employed in retail industry. And the machine learning, almost in all walks of life, we can have the machine learning applications, right from self-driving cars to credit card false reduction, online customer service, email spam reduction, business intelligence, and we can have n number of applications of the machine learning. This is what the main difference between machine learning and data mining. Next, we are going to see what are the main components of machine learning. There are mainly 4 components in the machine learning. They are collecting and preparing the data, choosing and training a model, evaluating a model, and hyperparameter tuning and prediction. We'll go through each and every phase in brief. First, collecting and preparing the data. The first and foremost step in the machine learning algorithm is that we need to have the data. That is nothing but we need to have some sort of base to gather knowledge. That the base is nothing but a data set. And the data is divided into 2 parts. The data set, and I mean data set. Data set is divided into 2 parts. It is nothing but the training data, and the other is nothing but the testing data. Training data is nothing but a large portion of data will be studied by the machine to find the patterns or to get the knowledge from it. So major portion of the data should be in the training part. The testing part is nothing but knowledge which we developed using the training part need to be validated whether knowledge is correct or whether knowledge is giving the correct output or not. For that, we need to have some portion of data, very small amount of data should be there for the testing portion. For example, consider that you want to build a software which can identify a person as soon as it sees the photo. So I assume that this is an application that you want to build a software which will identify the person as soon as you input the photo. The first and foremost step is that you need to collect the data. For example, it is being implemented in an organization. You need to collect the photo of all the people in the organization. The first and foremost step is that collecting the data. Collecting the photo in the organization is the first step. Once you collect all the photos, then we have to make sure that the data is the complete representative of the entire population. In the sense that whether we collected all the photos of all the people working in the organization. And we should also make sure that all the photos are of recent. Someone cannot give a photo when he was at the age of 1. No, that is not possible. The recent photo should be collected from all the people in the organization. That is also should be make sure. In other words, we can have to make sure the data which we collected should be valid at the current point of time. Once we've done this, this is the first step. Once we've done this, then we have to split the data in the ratio of, generally it will be split in the ratio of 80-20 or 70-30. 80-20 in a sense, 80 will be for training data and 20 will be for testing data. 70 or otherwise we can have 70% for the training data and 30% for the testing data. Anyway, as the model goes, we can split the data accordingly. The first step is the collection and preparing the data. The second component of machine learning is that choosing and training a model. We have n number of machine learning algorithms and models which have been created and which has been slightly modified to improve the performance so that it can solve a particular kind of problem. We have n number of machine learning algorithms. So from the n number of algorithms, we have to choose a model that is suitable for our problem. So we should know which model and which algorithm is suitable for what kind of problems. Based on that, we have to find for our problem which algorithm is suitable. Then we have to pick that particular machine learning model for our problem. That is called choosing and training a model. When you put we have to select the suitable machine learning algorithm. Once we selected the suitable machine learning model, then we have to train the model with the data, training data. Next is evaluating a model. So once a model is trained, second step is that we have to choose a model and then train the model. The machine learns the patterns and the features from the training data. As I said, once the data once the model has been chosen, we will give some data for training. The machine learns the patterns and the features from the training data and train itself. The knowledge will be slowly built in the machine so that the machine can able to take decisions by identifying, classifying, or predicting the data. For example, the same example I will give there. The photo example in organization. Once we choose a model for that problem, the data will be trained in the model. The training, the machines will identify the future of a person and it will build the knowledge. Later, when that person appears before the application, his features will be matched with the already trained features. Whichever person which is stored in the brain features matches with the person which is available in front of the application, then it will say, the application will say the person in front of the camera is X. How it identify? Because already the features which is trained will be there in the machine knowledge. Now the machine is lively capturing the image of the person who is in front of the camera. The machine learning algorithm again try to capture the features and then it will analyze with the trained data. Once the features are matches, then it will say this person is X. Again, we need to find how this model which is built in the training or the knowledge which is built in training is accurate. For that, we need to evaluate. That's what the third phase we're going to evaluate a model. To check how accurately the machine is able to take decisions, the prediction ought to be tested. That's why in the first step, we have divided 70% for training and 30% for the testing. The remaining 30% of the data which is not used for training, that will be taken as an evaluation parameter for testing, for evaluating a model. So in this case, we'll first work on the training data. And once the model is sufficiently trained, we use the testing data to understand how successful the model has trained to recognize the faces in the photo. The last component is that hyperparameter tuning and prediction. In machine learning terminology, the hyperparameters are the parameters that cannot be estimated by the model itself. It's a very important point that hyperparameter tuning and prediction. Hyperparameters, some of the example, like for example, if you use the decision tree, one of the hyperparameter is nothing but the number of leaves or the depth of the tree. So the hyperparameter. One such example is like that is a hyperparameter. Or suppose you use a deep neural network, the number of hidden layers is called as an hyperparameter. So based on the evaluation percentage accuracy, based on the evaluation accuracy which we are getting, we can also tune the hyperparameter, which in turn increase the efficiency of the machine learning algorithm. That's why I say hyperparameters, the parameters are not estimated by the model itself, but we need to account for them as they play the crucial role in increasing the performance of a model. This hyperparameter plays a crucial role in getting a high number of accuracy. So once we got 87% accuracy in a problem, for example, in the photo detection, we want to increase that to 95. Then we have to tune the hyperparameter. We cannot change the algorithm because a machine learning algorithm we can't change, but we can tune the hyperparameter so that the accuracy will be enhanced. Traditionally speaking, the hyperparameter in the machine learning are the parameter which need to be specified by the user. How many number of hidden layers should be there in the deep neural network? How many number of depth or what is the height of the decision tree should be? All these things can be specified with the user so that the accuracy can be improved. This is the fourth component in the machine learning. Machine learning algorithm is broadly classified into 4 different kinds, like supervised machine learning algorithms, unsupervised machine learning algorithms, semi-supervised machine learning algorithms, and reinforcement machine learning algorithms. We're going to see a short brief about all of these algorithms. The first one is the supervised machine learning algorithm. As the name goes, we will train the machine with the help of some supervisor or a teacher. The machine will be trained always in the presence of a teacher. So this training a machine or supervised learning will happen. It's a learning in which we train the machine with the help of the data. And the data should have a label in it. This label is nothing but the data which is already having the answer in it. That is called labeled data. So supervised learning, we're going to train or we're going to teach the machine using the data that contains the correct output in it. That is, we can say that it has a well-labeled data. So the output also will be there in the data, and we are going to train the machine along with the correct output. That is what the supervised algorithm. Supervised algorithms will always have the presence of a tutor in it, by which the machine is being trained with the help of the data, which contains the data which is already tagged with the correct answer. That is called as a well-labeled data. So after the machine is being trained, somehow we need to test the knowledge. As when we say training is happening in the machine learning, it means that the knowledge is being built. Once the knowledge is being built, definitely we need to test the knowledge. As I said, in supervised machine learning, we will divide some portion for the training and majority portion of the data for training and few portions of the data for testing. So once the training happens, when the knowledge is being built with the majority of the portions of the data set, we need to test the knowledge with the few data, like 70, 30, 80, 20 ratio, which I said in the previous slide. Now we're going to try, if we train the data with 80%, remaining 20% will be for the testing. The trained knowledge now it has to be tested with the testing data. So after the machine has trained, the machine has to be tested. So that is being done with the help of the testing data, and that will give the results. So we'll see an example how it goes. For example, you have a basket, and this basket contains many fruits like grapes, apple, banana, mango, etc. And now you want to train a machine that whenever you give a fruits from this basket, any fruit, single fruit, the machine learning algorithm should output the correct fruit. This is what an ultimate objective of this algorithm, imagine. And we're going to train the machine learning algorithm with the help of supervised. We're going to train the machine with the help of a tutor or a teacher. So the first step is that we need to train the machine with the supervised learning algorithm. So first step is that what we'll do, we'll say to the machine that this is a knowledge, this is the training which will happen. That I'm a teacher, I'm training a machine like this. I will train the machine that if we encounter an object which is rounded and which is have a slight depression at the top, and if the object color is red, then you have to give label as that fruit as apple. That I'm training, I'm a teacher, I'm training a machine like this. Like if the shape of the object is rounded and if it has a slight depression at the top, if the color is red, then the object is apple. Again, I'm going to train the machine with a different set of data. If the shape of an object is a long cervical cylinder, and if the color is green or yellow, then label that fruit as a banana. So I'm a teacher, I'm training the machine. Training the machine means I'm saying that these are the features. If you encounter these are the features, then you have to categorize as one fruit. If you encounter the different set of features, then you have to categorize as another fruit. That's why I'm training a model. It's a tutor. Supervised learning will always have a teacher. It will say that if you encounter these features, that you have to categorize as apple. If you encounter as this set, another set of features, you have to categorize as banana. If you encounter a different set of features, you have to categorize as another set of fruits. For example, I can easily give analogous example like how you teach a child alphabets. When a kid is at 3, when you show a alphabet and you teach your child this is A, that's called training. You are training a child to recognize the alphabet A. So again, you train a child to recognize alphabet B. Like that, you will repeat, or you train your children or kid to recognize the alphabet from A to Z. So that is what how the training will happen. Same thing that training will happen in the machine. So once the training is done, then we have to test it. That is what the next slide is all about. So now we already trained the features of the fruit which is there in the basket. Now we want to test whether the training happens perfectly. So now the knowledge has to be tested. So I will give a banana. Last project that I will give a banana. So now suppose after the training data, you need to have a separate fruit. Separate fruit in the sense that you have to test only on what you have trained. You not test jackfruit. Jackfruit cannot be tested with the knowledge which is developed in the previous slide because jackfruit is not in the basket. You have to test only for the data which you have trained. So I have banalized there in the basket. So I'm going to give this to the machine and I want to check whether the machine will be able to detect whether this is a banana or not. That is what my objective. This is how the testing will happen. Since the machine have already learned how the banana will look, what are the features of banana, those things will be learned in the training phase. So the testing phase I just given the banana. Since already the machine has learned the features of a banana, the machine will classify, machine will look at the object and it will say and it will recognize it is a cylindrical and the color is yellow. So then it will categorize this as a banana. And it will put this fruit as a banana category. This is how the trained data will be tested. So I will correlate with the child alphabet. Once you train your kid by showing the alphabet A as A, B as B until Z, you know, test it. The testing will show whether you have taught correctly and the child has grasped the item which you have taught. Unless otherwise you test, you will not know whether whatever you taught might have reached the child. So definitely testing should happen for anything. So after some time, you teach for 2 to 3 days to the child A to Z alphabet, they'll be showing the alphabet. On the 4th day, if you show any of the alphabet, the child should be able to recognize and say the correct alphabet. If you show C, the child should say C. That should happen. That is called testing. So once the test result is correct, then we can confirm that training has taken place perfectly. This is how the supervised learning works. This is an example. So supervised algorithm can be again classified into 2 types. One is classification and another is regression. And this classification example is nothing but which we have seen now, how to recognize a fruit from the basket is the best example of classification. And regression, when suppose if we want to have the prediction of a stock price in 1 year from now, we have a Wipro stock, and I want to know what is the Wipro stock price will be 1 year from now, then we'll use probably the regression supervised learning algorithm. The supervised learning will be broadly classified into classification, supervised algorithms, and regression. So as I said, this is how we will train a machine, and this shows the pictorial representation of it. So some of the broadly used supervised machine learning algorithms are K nearest neighbor, decision tree, Navi bias, logistic regression, and support vector machines. Again, these algorithms will be split into classification and regression. Next, we are going to see about unsupervised machine learning algorithm. As we have unsupervised tag in the machine learning algorithms, it means there will be no teacher or there will be no training will be provided to the machine like in the supervised. In supervised, we'll train the machine and we're going to test it. Whereas in unsupervised, we will not have any training component. So unsupervised learning is a training of the machine using the information itself. It means in other sense, we will not give any training because there is no tutor. We don't have any guidance here. There is no any guidance how the machine will learn. The machine will try to learn from the data itself because we don't have any tutor here. Very important point. What will do, the machine will itself will try to find something from the data because there is no one to teach. We are going to only giving a junk data to it. In those cases, the machine will try to learn from the data. The task of the machine is to group the unsorted information. So the machine will try to group the data. If you give only data, the machine will try to group the data and it will slowly try to find what are the similarities between it, what are the differences between this, and it will try to build a knowledge. I'll give another example for the unsupervised algorithm. Suppose you leave a child in a small room which contains balls of multiple colors. Initially, the child will play for some time. After some time, what does it do? The child by itself will try to collect the balls of same colors. This is what the finding the patterns. Here, the training is not given to the child. What does the child do? The child will select, or child will try to find the similarities between the given balls. The similarity here is nothing but the color. The room has n number of colors balls in it. The child, after playing for some time, slowly it will start to collect the balls which is of same color and it will assemble it. That is what finding the similarities and finding the patterns. Here, no training will be given in the unsupervised algorithm, but the machine will try to find the similarities or the differences or patterns by itself without any training data. So therefore, here in unsupervised machine learning, the machine is restricted to find the hidden structure in the unlabeled data. For example, suppose the picture which is projected, please look at it carefully. Suppose it is given an image. The image is projected which contains both cats and dogs. And now the machines will not have any idea about what is cat and what is dog, but this is what given. This is an unsupervised algorithm, so you will not train the machines up. You will not train the machine about the futures. Just you are giving the data. So what does the machine do now? The machine will try to analyze each and every object in the data, and it will slowly try to find out the futures, and it will see which of the object has a similar features, which of the object has a different set of features. Slowly it will learn by itself, not by external forces. Thus, here see the machines have no idea about features of dog and cats. So machine directly cannot categorize this is left is dog, right is cat. No. The machine slowly learns the similarities between the objects, pattern, and the differences between it. And based on the knowledge which itself, which will learn by itself, we can able to categorize which is dog and which is cat. First, it will analyze the features by itself. It will learn the features by itself, and then it will try to categorize it. And it will say 1 is dog, 2 is cat, 3 is dog. This is what an unsupervised algorithm is. Again, unsupervised algorithms can be classified into two broad categories, like clustering and association. So in clustering is thing where you find to group the similar object in the data, and on grouping this we will identify the behavior. So clustering problem is where you discover the same inherent properties or inherent grouping in the data such that the grouping will have the same behavior. Whereas in association, where you will discover rules that if a customer buy a product X, he will tend to buy Y. Those kind of association. If X is there, then there's a probability of Y occurrence is also high. Those kind of association between the two items can be come under the unsupervised machine learning algorithms. Next, third category is that semi-supervised machine learning algorithms. In this type of learning, in semi-supervised machine learning algorithms, we'll have both the labeled and unlabeled data. Labeled data is nothing but the output will be also trained. That is called label. Output which you're looking for will be there in the dataset itself. That is called labeled data. The machine, the semi-supervised machine learning algorithm will have both these labeled data and the unlabeled data. So typically in semi-supervised machine learning algorithm, we will have a small amount of labeled data and we have huge amount of unlabeled data. The first and foremost step in the semi-supervised machine learning algorithm is that the program will try to cluster the similar data. The program will try to group the similar data using the unsupervised machine learning algorithm. Then they will use the labeled data for the rest of the unlabeled data. The next first step is that they will try to group the similar data together with the help of an unsupervised machine learning algorithm. Then they will use the existing labeled data to label the rest of the unlabeled data. The typical use case of this semi-supervised machine learning algorithm is that it will first find the common properties between the unlabeled data. The common properties between the unlabeled data is done by the unsupervised algorithm. Then it will try to label the data with the help of the data which is already labeled. It will try to label the data which is unlabeled with the help of the data which is already labeled. These are some of the practical application of semi-supervised algorithm, like speech analysis, internet content classification, and protein sequence classification. Identifying the audio files is a very, very intensive task, and semi-supervised learning plays a very natural approach to solve this problem. And the second application is that internet content classification. So that categorizing each and every web page is really an unfeasible process, and this semi-supervised machine learning algorithms plays a very crucial role in classifying the internet content. And even the Google uses this semi-supervised learning algorithm to rank this web page. And DNA strands are typically very large in size, and this semi-supervised algorithm is slowly emerging in this field to classify the protein sequence in the DNA. Next, fourth type of algorithm is nothing but the reinforcement algorithm. The reinforcement, again, it's a part of the machine learning algorithm. The ultimate or the main feature which is predominantly popular in the reinforcement algorithm is that it takes suitable actions. The reinforcement machine learning algorithm will take suitable actions to maximize the reward in a particular situation. We'll see what is the reward in the forthcoming slides. So reinforcement algorithm is different from the supervised algorithm in the way that supervised algorithm, in supervised learning, machine learning algorithms, the training data has the key. The key is nothing but the label which you're going to find. So in supervised learning, the training data has the answer key with it. So the model is trained and with the correct answer itself. Whereas in the reinforcement learning, there is no answer. So what we expect that will not be there in the data. That's the key difference between the supervised learning and the reinforcement learning. In supervised learning, we will train the data with the output. What we expect the output, that will be trained. That will also be there in the training data. Whereas the reinforcement learning, there will not be the answer. The output which we expect, that will not be there. Please make a careful point note of it. The reinforcement learning, there will not be the answer in the training data. But the reinforcement agent decides what to perform the given task. So if there is no training data, it tries to learn from its experience. So this is a good example by which you can really appreciate what is reinforcement machine learning algorithm. So the problem is this. We have an agent, this robo is nothing but an agent, and we have a reward. The diamond which is projected in the picture is nothing but a reward. And we see so many hurdles in between that agent to reach to the reward. There are so many hurdles. Now the ultimate objective is that the agent is supposed to find the best possible path to find the reward. So this example is a best example to explain the reinforcement machine learning algorithm. Somehow the agent, nothing but the robot, has to find a path such that the path will have the maximum reward, such that the path is the best path to reach the reward. That is what the ultimate objective. Here, the agent is nothing but the robot, reward is nothing but a diamond, and the hurdles are nothing but the fires. Now, somehow the agent robo has to find the best path so that it can reach the reward. So, the goal of the robot is to get the reward, that is diamond, and avoid the hurdles that are fire. So, the robot now slowly learns by trying all possible paths and then choosing the best path which gives him the reward with the least hurdle. So now what will happen? The robot will try different possible combinations such that it will reach the reward. Maybe 5 paths, imagine. Among the 5 paths, it will now analyze which path if he has chosen, he will get the reward with the least number of hurdles. That will learn by the robot. So each right step will give robot a reward, and each wrong step will subtract the reward from the robot. Then at the end, when the agent, nothing but the robo, reaches the target, which is nothing but the diamond, the total number of rewards will be calculated. And when it reaches the diamond, it will calculate how many rewards that path has encountered. And based on the number of rewards that the path encounter, the best path will be decided. This is the best example of the reinforcement learning algorithm. So please see the 4-element agent. The agent is nothing but the program you train with the aim of doing the job you specify. The agent is nothing but the robo, which I shown in the previous slide, is nothing but the program you train with the aim of doing the job you specify. And the environment is nothing but the real world or the virtual world in which the agent performs the actions. An action is nothing but the move by the agent which causes the status change in the environment. And the rewards is the evaluation of the action, which can be either positive or negative. These are the 4 elements in the reinforcement learning algorithm. And the reinforcement learning algorithm, please have a look at it. The agent will act on the environment, and the environment will, the action in the environment will be either positive or negative. And and this action by the agent will cause a state of change in the environment, and in the environment will say whether it is a reward or it's a failure, and it will again give to the agent. Again, agent, based on the feedback from the environment, again it will try to adjust itself, and again it will perform some actions in the environment. Again, the environment will say whether it is a positive or negative, then again it will give to the agent. This is how the reinforcement algorithm works. So these are some of the main points in the reinforcement algorithm. The input will be in an initial state from which the model will start, and output. There are many possible outputs, as there are a variety of solutions to the particular problem. And the training is based upon the input. The model will return a state, and the user will decide to reward or punish the model based on its output. The model continues to learn. See here, the best thing is that there will be many solutions, and the models will continues to learn, and the best solution is decided based on the maximum reward. This is how the reinforcement learning algorithm works. Reinforcement learning will always find the best solutions, and the best solution is always found from the maximum reward. These are some of the real-time applications of the reinforcement algorithm. This reinforcement algorithm is used in robotics for industrial automation. It also used for data processing, the machine learning. It is also used to create training systems that provide custom instructional material to the requirements of a student. And this reinforcement algorithm is used largely in the environment where we only want a simulation model of the environment. We have where when we need a model of environment is known, but an analytical solution is not available. And third, this is used only way to collect information about the environment is to interact with it. These are the ways by which this machine learning reinforcement machine learning algorithm is used practically. Next is the deep learning. Deep learning is again another subset of machine learning algorithm. This is a field that is based on learning and improving on its own by examining the computer algorithm. So previously we have seen the reinforcement learning algorithm. The reinforcement learning algorithm will give many solutions, and the best of the solution is determined based on the rewards. Here is now we are going to see the deep learning algorithm. Here, in deep learning algorithm is nothing but the algorithm which learns and improve its learning by itself by examining its own computer algorithm is called deep learning algorithm. So deep learning is a computer software that mimics the networks of human brain. You know that neurons are nothing but the functional unit of the nervous system. So the neurons will transmit information very fastly the nervous system, and then it will allows the brain to take some actions. This deep learning, it mimics the neurons in the brain. It is called as deep learning because it makes use of these deep neural networks. And in deep learning, the learning phase is run to the neural networks. We'll see the architecture of the deep learning. So deep learning will, in abstract view, it will be looking like this: input layer, hidden layer, and the output layer. The hidden layers may be many number of layers. There is no any fixed number of hidden layers. We can have a number of layers in between it. And this is how the deep learning layers will look like. The first layer is input layer, and the last layer is output layer. All the layers in between are called hidden layers. So very important slide. So in general, for example, we take image processing. where you try to extract the features manually in the images, and then you will try to find out the object, whether it is categorized, whether the object is a cat or a dog. In general, image processing, the practitioners is used to extract the features in the image like eyes, nose, lips, eyebrows, and many features. But these features are extracted, and they are given as input to the classification model. So deep learning solves this issue especially as a convolution neural network. The first layer of the neural network will learn small features. As I said, we have a number of layers. The first layer in the deep learning for this image processing application, it will learn the small details from the picture. And the next layer will combine the previous knowledge from the previous layer, and it will make the knowledge more complex. So in convolutional neural network, the feature extraction is done with the help of filters. The network applies the filter to picture. The network applies a filter to the picture to see if there is a match. The shape of the feature is identical to the parts of an image, and if this matches, the network will use this filter. The process of extraction is therefore done automatically. So for example, in traditional machine learning, you see the feature extraction is another crucial research problem. When you have a machine learning algorithm, when you have a data set, what are the features are important for the particular problem? Identifying the features for the particular problem itself is a big task. The data set is very small. If the data set is containing only 5 to 6 features, you need not have to select the features. But imagine generally that is not the case in the machine learning algorithms or the deep learning algorithms. When you have a data set, the data set will be of huge size. We'll have thousands of features. So for the problem, given problem, or not all the 1,000 features will going to help to get the results. Definitely, we need to limit the features. Definitely, we need to select the best features from the 1,000 features so that we'll get a high accuracy. If you train all the 1,000 features, then training itself will take years to build the model. Definitely, we need to filter out some of the features from the existing features that is relevant for the problem. The selecting a feature for the relevant problem itself is a big task and big research problem. How to find the best features for the particular problem. Feature selection itself is a big task. In traditional machine learning, we need to first select the features for the given problem, then we apply the classification algorithm. Whereas in the deep learning, this is inbuilt. The deep learning algorithm itself will try to extract the features which is relevant for the problem, and then it will give that as an input for classification algorithm. That is what the picture which is portrayed here is giving. Deep learning algorithm itself, you need not implement any algorithm to select the features for the machine learning problem. If you deploy the deep learning algorithm for the given problem, the feature will be automatically extracted from the data set for the problem, and it will give to the classification problem. That is what a very important step in the deep learning. So now we're going to see the difference between the machine learning and the deep learning on the 5 different important features like data dependencies, hardware dependencies, feature engineering, execution time, and interpretability. In data dependencies in machine learning, we have excellent performance. The data set is small and medium. But to have excellent performance in deep learning, we need to have a really big data set. And for the machine learning algorithms, hardware dependencies, like it will work on a laptop. But for the deep learning, we need a system which preferably good GPU and significant amount of memory. And for the feature engineering, machine learning, need to understand the features that represent the data. Like you need to have a thorough understanding of the features in the data set. Whereas in deep learning, need not have to have a thorough understanding of features because the feature itself will be extracted by the deep learning algorithm. Next, execution time, as I said, it will take few minutes. But for the deep learning algorithm, it will take some weeks to get the output because it has to learn the features, then it has to give that as to classification algorithm. So it will take some time. So interpretability, some algorithms in machine learning are very, very easy to interpret, like logistic regression and decision trees. And somewhat very difficult is nothing but SVM and XGBoost algorithms. And the results of the deep learning algorithms are almost difficult, and sometimes it is also impossible to interpret the result. So now questions will come to your mind when we should use this machine learning algorithm and when we should use the deep learning algorithm. So whenever you have a very small data set, preferably we'll use the machine learning. And whenever we have a data set of very large size, then we'll use the deep learning algorithm. And whenever you know for the problem, these are the features has to be selected from the data set, then we'll use the machine learning algorithm. Suppose if you have no idea about the features for the problem which you're going to work on, and there are many number of features in the data set, then you'll use this deep learning algorithm for that kind of problems. And machine learning, there are many algorithms available, and for the deep learning, we have very few number of algorithms. And as I said, training time for the machine learning algorithms will be short, and for deep learning algorithm, it will be long. These are some of the typical application of the deep learning algorithm, like self-driving cars, Google self-driving cars, and it is used in the healthcare. It is used in voice search, voice activated assistance, automatically adding sound to the silent movies. It is extensively used in natural language processing, automatic machine translation, automatic text generation, automatic handwriting generation, image recognition, automatic image caption generation, and predicting earthquakes. There are a number of applications. I have listed some of the top applications in which the deep learning plays a crucial role. So far now we've seen what is the machine learning, components of machine learning, and different types of machine learning algorithms. So machine learning algorithm has to be implemented for the research purpose. There are many tools which is being available for the implementation, but then Python being its open source, it has been extensively used by the researchers. So some of the popular libraries in the Python, it's been projected here. We have scikit-learn, and this is mainly a Python machine learning library, which has many algorithms inbuilt in it, like classification, clustering, regressions, can be directly used from this scikit-learn. And we have also NumPy and SysPy, which is mainly used for numerical and scientific computations. Next, we have a TensorFlow. Again, it's an open source software library for high performance computation, like deep learning and all will use this. Next, we have a Keras. Again, it's a deep learning library used to develop neural networks and other learning models. So now we have seen machine learning, we've seen deep learning. We need to have established some kind of relation. Is there any relation between the deep learning and the machine learning? Yes, we have a relation, and it's being projected there. You can say artificial intelligence as a superset, and machine learning is a subset of artificial intelligence, and deep learning is a subset of the machine learning. So artificial intelligence is nothing but a technique for incorporating the human intelligence to a machine, and it is a superset of machine learning and the deep learning. And if you want to say the machine learning is a subset of artificial intelligence, and that consists of algorithms and statistical model used by the machines to perform a specific task and to improve the experience by the learning. And there is a mistake in the second component. Artificial is nothing but a machine learning. It is mistakenly given as artificial intelligence. Please correct it. And third is nothing but deep learning. It's again a subset of machine learning that uses artificial intelligence, especially the deep neural networks, for a computation purpose, that too with high accuracy. So what is the future of machine learning? How the machine learning is going to help us in the future? So it helps us to regularize the data, digital data. Now today, as I said, we are generating quintillions of data, and with the help of IoT, even more the data accumulation and the size is very, very large. And this machine learning algorithms help us to regularize the data, and it's really helping in the voice assistant, and it also helpful for the effective marketing. Many machine learning algorithms are playing a crucial role in the business analytics, and it helps in many business to project themselves, market themselves based on the feedback, based on the prediction which is given by the algorithms. And it plays a crucial role in the robotics across the industry, and it has been extensively used for the chatbots. Nowadays, you can see the chatbots. Previously, when you contact some internet banking website, you want to call for toll-free number for any of the clarification queries. Now there is a chatbot which is available. That this chatbot is nothing but a person. You will be interacting with the computer, and the computer will try to solve a question which is posted by the user in the real time. That is called the chatbot. And machine learning is extensively used in the chatbots. And the machine learning is also used in cybersecurity. So the machine learning algorithms will try to understand how this attack has been take place, and similar kind of situation has been occurred in the future. This machine learning algorithm plays a very crucial role in detecting those cyber threats. These are some of the ways in which the machine learning algorithm is growing. A quick summary of the session. So we started with machine learning, and we discussed about various components of machine learning, how these machine learning algorithms have been categorized. We've seen supervised, unsupervised, semi-supervised, and reinforcement algorithm. We've seen the deep learning, application of deep learnings, and how these machine learning algorithms can be implemented with the help of Python libraries. And finally, we have seen about the future of machine learning. With this, we come to this one-hour webinar. And this is a quick bird's eye view of machine learning. We have, to be frank, we have touched only a tip of the iceberg. And really, if you want to learn in and out of it, you can read book on machine learning, or you can follow any of the online portal like Udemy, or that's a very good machine learning course by the Stanford University, which is available for free. So we have a lot many to do, and we have just only touched the tip of the iceberg. So for this presentation, we have used lavishly the resources from the internet, and I thank and acknowledge the same. Thank you one and all, and you can reach me in case of any doubt. You can reach me at thiyagu@cutn.ac.in. Thank you so much.
Dear friends, it's my privilege to propose here a vote of thanks in this occasion. I thank our most valued correspondent and secretary, Reverend Father Dr. S. Sebastian Perianan, who always inspiring us. I express my sincere thanks to our Father Administrator, Dr. S. Arakidas, who always helping us. I also wish to express my gratitude to our Principal, Dr. S. Suresh, for providing encouragement and support. I would like to extend a special thanks to our Dean of Science, Dr. M. Chitra Devi, for guiding us. I am very grateful to our HOD, Dr. K. Sujit, for giving us an opportunity to organize these events, as no program can become successful with a single person. So I extend my big thanks to our staff members of Computer Science Department for their support, and all of our volunteers too. Thank you guys for making this event successful with your contribution. I thank our most distinguished chief guest, Dr. P. Thiagarajan, Assistant Professor, Department of Computer Science, School of Mathematics and Computer Sciences, Central University of TamilNadu, Thiruvarur, for spending his valuable time with us. Thank you, sir. Last but not least, I thank all my participants who are assembled here for this webinar. Thank you, friends.